Hello, I am Carlos Ocampo Lopez from the Faculty of Chemical Engineering at Universidad Pontificia Bolivariana, and together with Professors Fabio Castrillon and Jader Alzate, we are going to present our work entitled Development of Capstone Integrative Projects as a Tool for Learning Design and Process Control in Chemical Engineering. According to different organizations for engineering accreditations, such as ABET, students must be prepared for engineering practice through a curriculum that culminates in a significant design experience based on the knowledge and skills acquired in previous courses and incorporating appropriate engineering standards and multiple realistic constraints. Engineering education in the 21st century requires the students get prepared to face the demands of complex and dynamic work environments. Therefore, the students need to be involved in experience that compresses complexity, innovation, and application of knowledge in a chemical engineering curriculum. To achieve this, the Faculty of Chemical Engineering at UPB have developed a final degree design experience called Capstone, which combines engineering design and economics for the synthesis, analysis, and optimization of basic processes in the context of chemical engineering. The Capstone course integrates the skills and competencies that the students have learned in their engineering program and should provide a simulated real-world end-to-end learning experience with external assessment. The construction of the Capstone design project was a gradual process that took several years to consolidate. Until 2000, the faculty worked on design experiences on process analysis focused on the calculation of mass and energy balances and sizing of process equipment. And by 2010, we began the implementation of numerical methods and simulations supported by software with an applied mini-project which strengthened the students' ability to develop engineering calculations. In the period between 2010 and 2015, an approach to the Capstone project began in the process design course with applied projects comprising, for example, simulation, optimization, financial evaluation, and elaboration of process flow diagrams. In 2016, the faculty implemented a curricular transformation that included integration between the process design and process control courses through a final degree capstone project, in which the students proposed basic engineering alternatives using engineering standards, evaluate process dynamics, and tuning of controllers. And this constitutes a project-based learning methodology. So the integration with process control and process engineering laboratory courses has allowed a better understanding of the concepts seen in the design course, as the students carry out simulations, stage opinions, and play with variables. That motivates them to work on different topics and concepts related to process control, and in this way make us use a motivational active learning. The students are organized into groups of approximately 4 members at random, it's very important, and are assigned a problem or situation or context to develop the capstone design project. The students perform a market assessment to define the plant capacity and propose alternatives for the design based on literature review, for example, and following environmental, social, and technical constraints that they must be aware of. The most promising alternative undergoes a conceptualization that includes the calculation of mass and energy balances and case studies supported by software such as Aspen HYSYS and Microsoft Excel, where the alternative is subjective to optimization. Subsequently, the students calculate the sizing of the process equipment using mathematical and heuristic models to later evaluate the process dynamics, its controllability, and estimate the tuning of the controllers. And finally, the students prepare a financial evaluation of basic engineering using Monte Carlo analysis to predict the profitability of the process plant and prepare process flow diagram, which they present orally to peers and external evaluators coming from the industry. The external view of graduates of the program who participate in industrial activities has served as a learning evaluation tool and feedback in the orientation of the Capstone project. And for this reason, and as a methodology, a focus group was developed with 5 graduates with 10 to 30 years of professional trajectory, advanced training, and most important, experience in the design area. The idea is to evaluate the quality of the Capstone project and the value it delivers to newly graduate professionals in a chemical engineering faculty. The graduate one, with 30 years of experience, is an expert in industrial research, innovation, product development, and academic administration. Graduate 2 applies disruptive thinking and sustainability to professional development in chemical and manufacturing processes. Graduate 3 has international academic experience with Capstone projects in Canada and Switzerland. And Graduate 4 accredits experience in new business development in the chemical industry. And finally, Graduate 5 as an employer of recently graduate professional and the management of high-performance teams. Additionally, an opinion query was first proposed of the graduates of the program with less than 5 years of professional practice to assess their perception of and relevance of the Capstone design experience in their training process. Here you can see as a result the evidence from some Capstone projects, for example the process flow diagram that our students prepare as a basic engineering to produce ethanol and methanol using rice husk. The students calculate balances, select the proper equipment, and communicate the design alternative following the standards for diagram creation in chemical engineering. And here you can see the evidence from the dynamic simulation and process control in a reactor to produce L-aspartic acid from rice bran. In particular, the students define a control strategy, select the instrumentation, the valve and controller action, and they also calculate the tuning parameters to assure the process controllability. They support the calculation in Aspen HYSYS. They use also MATLAB and Loop Pro software and assess that strategy. In this slide, we can summarize the results coming from the focus group and the opinion query. The graduates participating in the focus group consider the Capstone very valuable to developing the students an integrating vision of the chemical engineering. The construction of a proposal with technical, environmental, social, and economics viable solution to an industrial need or a specific technical challenge is successful, and as an integrating vision, Capstone covers all the aspects that an ideal chemical engineer of the 20th century has expected in the industry. The Capstone experience was evaluated as relevant for the students since it brings them closer to reality as chemical engineers. The planning process was highlighted, and they were invited to consider projects related, for example, to real challenge for the industry, including advanced technological tools such as machine learning to simulate, for example, the synthesis of the process. By the other hand, 59 graduates of the chemical engineering program in the period between 2016 and 2019 participated in opinion query, and it was found that 94% consider that it contributes to professional practice regardless of the professional subject they currently perform, and 78% consider this to be a highly relevant learning experience. The focus group also made it possible to identify improvement opportunities for the Capstone project with the integration of the design and process control courses. The experts suggest strengthening aspects such as the safety of the process and the deliverables, and incorporating methodologies for the identification of hazards, and an approach to a study of risk and operability. Other opportunities for implement include the involvement of athletes, one industry sponsor during the development of the Capstone project to generate mini open innovation challenges in which the students receive feedback of the current state of the chemical sector, as well as incorporate within business model projects and evaluate proposals related to, for example, circular economy and the search of carbon neutral processes and products that take the advantage of biodiversity or that incorporate the principles of food chemistry. And this feedback makes it possible to continuously improve the relevance of the Capstone project in the training of chemical engineers required by the industry. As a conclusion from this research, the Faculty of Chemical Engineering of Universidad Pontificia Bolivariana developed an integration in the design and control processes courses to incorporate a project-based learning methodology through the Capstone project that has improved the meaningful learning for students. The students showed an improvement in their competences by implementing computational tools for the development of Capstone project in the courses, increasing the capabilities to investigate, to make decisions, to design and integrate the concepts. Some strategies were implemented to improve students' learning of design and control, which involve external evaluation, process control coming from the industry, and the learning results allow us to improve the development of the integrating courses, and in particular the stability, the controllability, or the tuning of controllers was improved. 99% of graduates in that period recognize that Capstone projects and the project-based learning methodology is very valuable for the professional development of our chemical engineers. And the focus group with 5 graduates, expert in chemical engineering, validate the relevance of the integration between control and design courses. The idea is that this experience was evaluated and defined as relevant, and the opportunities to improve this experience was linked with members or sponsors of the industry, incorporating topics related, for example, to green and sustainable chemistry in the design proposals. Thank you very much.